very major setback or a misfortune for all of us. How is our solution better than others? Here are the reasons or the features for the smart solution which we are proposing. It will be fully automated. There will be less human interventions. Because of that, there would be less chances of errors. Solar powered. We propose to introduce our system solar powered, majorly solar powered, and which will be partially electrically powered, depending on different seasons and depending on the day and night sequence. Higher efficiency, as I previously mentioned, that it will be fully automated, so it will have more efficiency because less human is involved, and it will be AI enabled, which will be synchronized with the traffic signals as well as with the traffic management control centers. Efficient and accurate sensing modules. This system will consist of accurate modules that will be high resolution cameras, high resolution, high accuracy cameras, and different modules like ANPR modules, IR modules, and so on for our solution. So the further technicalities will be discussed by Akshay.
So, good morning, everyone. So, these are few of our proposals for smart traffic system in order to ensure pedestrian safety. So, first one is the AI-based cameras and sensors which will be installed on roads. They will surely help in determining the density of the vehicles on the roads using image processing, and accordingly increase or decrease the duration of traffic signals to reduce congestion. So, for example, if one lane of the road is having high density, the number of vehicles is more, then the duration for which the green signal will be on will be increased, and if the number of vehicles is less, the duration for red signal will be increased. So this will surely reduce in congestion. It will also establish an accident alert system coupled with surveillance system. Also, there will be vehicle behavior monitoring system. The second one is the hydraulic or motorized system on road intersections. This will consist of retractable gates at areas with less congestion on intersections, that is, and automatic rising fence wherein the areas are more congested. So this system will be solar powered and synchronized with traffic signals. Next slide. So yeah, coming to the IoT systems, we'll be using advanced artificial intelligence, which will not just only detect accident, but also there will be a quick return control actions in such a way that an alert will be sent directly to hospitals or ambulance or traffic policemen in real time. So our system will be based on neural networks and deep learning, wherein there will be several methods and algorithms. Our approach will be such that the system will work on still images, recorded images, real-time videos, and in that way it will detect, classify, and also compute the vehicle, the object velocity using convolution neural networks. Next slide. So these are what retractable gates look like. So we are proposing this because there are incidences when the commuters, the drivers are distracted and miss the traffic signals, which may result in an accident if a pedestrian is using the zebra crossing. So this retractable gate will close once the traffic light turns red and will open once it turns green. So it will be solar powered. Also, if the density of vehicles at intersection is very high and the authorities cannot put up retractable gates, we propose of installing automatic rising fences, which will be based on hydraulic systems. So I would like to make up a point here that these systems are used widely in foreign countries, but not India. So these are the two proposals which we are making for improving the road safety in our country. So so why are we keen on introducing such methods in our country? Because road safety is a topic which has been ignored for quite a few years, but now the government of India is taking progressional steps, such as in this year 2021 February was named as the Road Safety Month, and so this proposal will be a stepping initiative in this process. Also, the United Nations Conference of Trade and Development, that is UNCTAD, has expressed Agenda 30 for Sustainable Development, and in this they are aiming to reduce the global road accidents, road traffic deaths, and injuries by about 50%, and to provide safe, affordable, and accessible transport system, which will wherein there will be safety for all. So yeah, so this proposal will surely help in the society as a whole. So that's it from our side. We are open for suggestions and questions. Thank you.
Thank you, team. I would request Sir to please ask the question.
Hello.
Yes, sir.
Your idea is good, but I am not able to find that everything happens to be the planning stage. Have you executed anything?
No, sir. No, sir. We have just started our plan.
Okay.
We are going to work forward.
So these are the things you are going to include in future.
Yes, sir. Yes.
So this work is a part of your college project, or
No, sir.
independently you are doing?
No, sir. We are independently doing this.
Okay, very good. So that is good. But you implement it, then only we can count your contribution. But this is encouraging that you participated in that particular session.
Okay. Yes, sir. Thank you.
That's it.
Okay, I have a question that there are two separate things if we can see. The mechanical system for pedestrian safety is one thing, that is a separate matter, and secondly you are addressing the traffic congestion issue, it seems. So for
Yes.
traffic congestion, why you need an artificial intelligence system? We already have GPS based mobile app, no, which shows where the traffic congestion is, even for the drivers. So how will your system will be different, and why there is a need of this system?
Okay. Ma'am, in the present scenario, there are many places where we cannot use the alternative roads in order to achieve or in order to go somewhere. So this system will enable, if there are, you can see that there are many highways. Only particular highways are there to achieve to go from one city to another city. So we can introduce these systems there so that our flow of traffic will be uniform and will help the people around there and ensure their safety as well.
Yeah, okay. Now, I mean, my question is, see, when we go for artificial intelligence system, you need to have that, you have shown, no, you need a test data, then
Yes, ma'am.
then the real data and all those. So
Yes, yes.
whenever you are not, like for example, fuzzy logic and all neural network based systems, when you are not sure about the decisions, you have to look at the history and infer something and take a decision. This is a layman's language I am telling you about artificial intelligence. But in your case, in real time, we do have this data in hand with the GPS, right, where the congestion is rightly going on, or in next few minutes where the congestion will increase, and all these things can be done with the help of GPS data. So do you really think that artificial intelligence will have some role in this application?
Yes, ma'am, I do believe that there will be a role because even if many people have GPS, then too they are stuck in traffic. So there might be some place for this artificial intelligence.
Okay, ठीक है, let's see. All the best.
Thank you, ma'am.
Thank you, ma'am.
Good attempt.
Reshma ma'am? Okay, there is a lot of research in this area. What you have talked about smart traffic system for pedestrian safety. If you're talking about highways, actually, see, highways, we don't have this pedestrian, what you say, safety when we talk about highways and expressways, because there's no road crossing there. Fine. and there's no footpaths there. So I guess where you are using this,
Ma'am, the pedestrian safety is for the intersection of roads, basically where the accidents occur most of the time. And for highways, we are ensuring that there might not happen any accidents, or we can prevent them beforehand by giving a notice to the nearest police station or to the patrolling team nearby, so that and artificial intelligence would be in, involved in that sense. So, and that's all.
okay, fine. Okay, done.
Okay.
Thank you, Team E5. I would like to inform everyone that right now our event is going live on YouTube, and I hope all the audience are enjoying the interesting presentation and the research work done by all the participants. So next, I would like to say our next team will be judges A4. So team A4, you can start with your presentation, please.
Hi, good morning. So I just have one issue. My bandwidth is actually a little low. So if I can turn off my video while giving the presentation, that would be very helpful.
Okay, that's fine.
Thank you.
Which team it is?
And it is A4 right now, and before it was A5.
Team A4. Just a moment. Yeah, my PDF is visible.
Yes, it is visible.
Okay, so shall I start? Before starting, I just want to have a small clarification. So if I want to do some scribbling on the screen, is that okay? So I have a concept to explain. So a little bit of scribbling would be very helpful actually.
Yes, yes.
Okay, so as judges have given the permission, you can go ahead with that.
Sure, okay. So I'll be starting. Good afternoon, everybody. So I'm Shubhan Modak from the Institute of Rural Management, Anand. I'm an architecture graduate and now I'm doing my master's in rural management. And today my topic is related to all the farming bills and farmers agitation that has been going on. And what I'm talking today is about a nationwide rural-urban network that I'm currently working on as a research proposal, and how I'm integrating that with Prime Minister Narendra Modi's One Nation, One Market concept. Along with that, integrating also the factors about price control and other aspects. So, at the base of my research proposal lies the two places, that is the urban and the rural. So, my proposal talks about proposing a structure that actually brings in economic equity between these two entities, the urban and the rural. So, moving on, what is the One Nation, One Market concept? It actually is a concept that came about in 2016, wherein our Prime Minister actually said that, okay, it will be a single one-off portal wherein people can actually buy the produce from the farmers directly. By people, I don't mean that people like end consumers, I mean companies. So it's a B2B or B2C channel, and companies can procure their thing for directly from the markets, or rather, if we want to, we the customers can also procure it directly from the portal, from the markets. So that, in essence, in a very short thing, is the One Nation, One Market concept. Now, if you look at the Farm Bills 2020, on which so much controversy is actually going on, it actually is entirely about implementing this One Nation, One Market concept in India. However, that discussion is predominantly missing from the market because almost nobody has been able to identify that, okay, how are the farm bills going to implement this One Nation, One Market concept? In essence, the three separate tracks or the bills that are there, how are they coming together and how are they proposing this ENAM concept? the short form is ENM. So I think my proposal on maintaining a rural-urban network kind of helps it do that. Before coming to my main proposal, I would also, apart from the one nation, one market concept, like to talk about price, the one burning issue that India is suffering from now on. So when it comes to price, and again, when it comes to agriculture or rather any goods, there are two nature of price control, dual nature. If you imagine it, it's a single line. At one end of the line is the farmer or the producer, and in the other end of the line is the consumer or the customer. Now, the produce or whatever is being produced moves along this line from the farmer to the consumer, and in the intermediate, there are stakeholders who are adding value. So, price regulation essentially is mandatory at both the ends, the farmer's end and the customer's end. As such, there are two regulators in the market, that is MSP and the MOP. Now, during doing this research, when I was thinking, I came up with the dual nature of it. So, how does it happen? At the farmer's end, the MSP is definitely the minimum support price, which we all have been talking about. It's a raging issue. And also at the farmer's end, there is another concept that I propose, that is the maximum offer price. So the minimum support price is something that the companies are giving to the farmer to help them survive. The maximum offer price is the price that the people are giving to the farmers, so as to ensure the fair competition, so that big bankable corporates don't actually pay so much that the small agribusinesses are lost out in the competition. That's on the farmer's end. On the customer's end, also there is the dual nature. So MSP's dual nature is the maximum selling price, which ensures that no business can rip customers off by charging so much that it's not actually affordable. The MOP version also has a dual nature, wherein it's the minimum offer price. The minimum offer price, what it does is it ensures that the business don't go bankrupt while trying to survive the competition. So yeah, in this model, in this price control model, I am actually trying to give the farmers their due by enabling kind of economic padding, and I'm also at the customers end giving them economic padding so that they don't get ripped off and the small businesses survive. Now, coming on to my main thing, what is the pan-India rural-urban network that I'm proposing? So I do have an interest in planning, and because I'm studying rural management, I'm getting into the rural-urban network planning. So in that thing, the rural-urban network is actually a nationwide network that will be enumerating the enabler network of village, town, city, metropolis for effective administration. Now, when I'm saying administration, it's not just farmers administration, or it's not just how the things are moving along the supply chain. It's actually administration in every basic sense. It's actually equitably distributing the economic policies so that a typical farmer doesn't have to come to the city nearest to him to actually gain their bread, but a model wherein the city can support the village by staying in its own place, wherein a city can support the village by giving the village the necessary stimulus, and that is where this entire rural-urban network related to the farming comes in. So, just a moment. Okay. I can't seem to draw, but anyways, no worries. So, when it comes to the rural-urban network, if you can just close your eyes and imagine a single straight line. At one end of the line is the rural, and at another end of the line is the urban. Now equate this. At one end of the line is the farmer, and at another end of the line is the producer. So the rural actually is synonymous to the farmer, and the urban is actually synonymous to the consumer. When it happens, if you are setting up a pan-India rural-urban network, essentially what you are doing is you are actually bringing the entire country under a systematic track. And when you do that, you can actually identify where the produces are being produced, through which supply linkages the produce is being transported, and the end destinations where the produce is being dumped. So that in essentially is the one of the main factors which will help ENAM, or the one nation, one market, to actually track the produce and identify the production points and the selling points. If this network is done, then actually that's like bringing the entire nation under a single framework wherein you can monitor and analyze everything. Also, when it comes to price control, you can actually segment that line to very small factors, to very small parts, wherein the price is increasing at a modular rate on every step. So suppose village 1 to town, there's a nominal increase, then town to the city 1, another kind of increase, modular increase, city 1 to city 2, another increase, and city 2 to metropolitan, that is the last and final increase. So if this network enabled network is under place, you can actually monitor the produce going through. You can also actually monitor the price control, or rather how the price is increasing at all the levels of the supply chain. So that in essence is my proposal. This is actually a research proposal that I was working on independently till now. Recently, our college, Irma Anand, also has the Varghese Korean Policy Lab, and they have actually accepted my research proposal. And once I am in campus, I'll be collaborating with the Varghese Korean Policy Lab and detailing it out. To end with, I also wrote an article on similar lines about agro-nationalism last week, which won the first position in a nationwide article competition. So, to end with, I'd just like to end with Abdul Kalam's Vision India 2020, wherein he has said that the rural-urban divide has to be reduced to a thin line, and all parts of India will become equally developed. So, I believe my proposal of setting up this rural-urban network and also my proposal of the dual price control will actually be very essentially helpful in setting up the ENAM concept. And to end with, this is not a product as such. This is a research proposal which will in the future, once the entire thing is over, will culminate into a policy framework or a policy document on which the ENAM or One Nation One Market can actually sustain. Not just the One Nation One Market. If we actually go for a rural urban network, then I think a lot of administrative issues in India will also be solved. I believe that's it from my side.
Thank you, Team A4. I would request Sir to please ask the question. Okay, ma'am, you can start first.
No, I mean, it's okay, sir.
Sorry, madam, I don't have any question. Please, you go ahead.
No, I mean, are you doing PhD or something?
I'm doing my master's in rural management, ma'am.
Masters.
I do have a fleeting desire of pursuing my PhD after this. I do see a career in research.
It's okay. So, you are essentially planning to solve any optimization problem. It looks like.
Kind of, yes, kind of.
You haven't discussed any constraint or any model in this presentation. It is a technical presentation competition. You haven't shown any model, mathematical model, not constraints, or any formulation as such, right now.
Okay, so I haven't actually reached that level.
Sorry?
I haven't actually reached that level yet. So I'm also like it's a very I'm growing into that, but not to that level yet, ma'am. Sorry about that.
Okay from my side.
Any other questions?
No, we'll move to the next team, that is A4. You can stop with the presentation. We'll move to the next team, that is A6.
Hello?
Yes?
Is my screen visible?
Yes, it is.
Okay. So should we start?
Yes, you can start.
Hello? Okay. So good afternoon everyone. Myself Ninad Vivek Joshi and I'm from Team Ashrand. I thank the Team SPECTRA 2021 to give us a chance to present our paper, Design and Finite Element Analysis of IoT-based Smart Helmet, which was submitted to IMtronics 2020, and it was published by IEEE Vancouver, Canada section in the last year, 2020, in month of October. So the group members are Ninad Joshi, Sumit Joshi, and Mallar Zozare. So now we'll have a look towards the points which we are going to discuss during this entire presentation, like introduction, market survey, then some mechanical part, that is CAD designs, FEA, and some AIML, that is data analytics part. So I ask Mallar to continue.
So I will be discussing about the needs of the project. The main reason behind the project was the safety of an individual. As you may know that delay in the medical help in road accidents may lead to the death of an individual. The system is integrated with sensors modules to provide a real-time monitoring for the safety measures. We are working on a project based on a smart system for security forces. By changing some features of the system, this can be implemented for common people. We get to know that. So, according to the market survey, smart helmets are costly. So, we are focusing on a cost-effective smart helmet, which will satisfy the needs of the users. Next slide, please. So, this is the literature survey we did. You can have a look. Next. So the components and materials we have used. The sensor we have used is a vibration SW420, and the modules we have used are GPS, GSM, and TI Boost Excel. The controller boards are TI Launchpad and the Arduino microcontroller. Next slide, Ninad will continue.
So as explained by Mallar, we have been using these components. So I'll explain these components with the help of the following diagram, that is sensor and module placement diagram. So you will get to understand it more better. So the red dots represents the vibration sensors, which will be placed in the same pattern as these components are decided with the placement with the industry experts as well as our faculty mentor. So the red dots represent the vibration sensors, which will be used to detect collisions. Then comes the green, that is the GPS module, which will be used to track the position, or for we can say the navigation purposes. Then comes the GSM module, the yellow circle, which will be used to transmit the message. It will come into action only if there is a need to transmit the message. Then comes the pink circle, that is the controller board, which is placed at the center so that all the sensors as well as modules are interfaced at an equal distance. Then the innovative part, it is the power bank, which will be a replaceable power bank, which will be situated at the bottom of the helmet. And then comes the TI Boost Excel, which is used for entertainment part. That is, we will discuss in the further slide. So now, till now, you have been familiar with our idea. Now the question comes that how actually the smart helmet will be working. So now on the left, you can see the smart helmet block diagram. So on the left, the vibration sensor GPS acts as an input to the interfacing controller board, and the output, that is the message, will be transmitted through GSM and the RF transmitter. So now the question comes that if the smart helmet is kept at a surface and it falls towards the ground, then the message will be transmitted and immediate help will be given. So to avoid this miscommunication, the team was facing some problems. So the team decided and came with the solutions that we are going to place a sensor inside a buckle, which will be so that it will work in the manner that whenever the buckle is engaged, the entire system will start working. And whenever the buckle is disengaged, the entire system will stop working. So this is an innovative idea. Now we'll consider that the sensor has been, that is the buckle has been engaged and the system has started working. So the our unit will be having two units. One is the safety unit and another one is the entertainment unit. In safety unit, the vibration sensor will be placed as discussed in the diagram. So it will be continuously checking for an input. If there is no input, it will return to the first block. But if the user is facing some or the other problem, that is frequency is greater than 40 Hertz, then the controller board will get actuated. And as soon as it gets actuated, it will transfer some or the other signal to GPS module and GSM module. And then in collaboration with GPS, it will transfer that message to the port, which we are going to design. That port will be completely working for this kind of help only. So now we are working on a code in such a way that that message, that string, that whenever the GPS transfers, it transfers in the format of anime string format, which stands for National Marine Electronics Association. So we are working on a code such that that string will be inputted as a CSV file, and whenever the code is run, we'll get the actual coordinates in terms of latitude and longitude, and accordingly help will be given. So in addition to this, we are also working on the entertainment part, which will be having play music or receive calls, etc. So in this period of lockdown, we were not able to get the actual hardware. So the team decided not to waste time and work on the virtual platform, that is the Protest platform. So this is the Protest platform where the vibration sensors are placed, then the controller board, GSM module and GPS module. And this is an example. You can see the here virtual terminal. So this is an example how actually the message will be transmitted and received at the port. So now the mechanical designs will be explained by Sumit.
Thank you, Ninad. So now we will go into the FEA simulations, the comparisons and the future scope. Next slide, please. So here we have the FEA simulations. So the CAD models were imported into the ANSYS environment for the FEA. So tetrahedral mesh was used for this analysis. So in the first iteration, as we can see, according to the BIS standards for helmets, 19.5 kN load was applied to the top portion of the helmet by fixing the bottom padding. And in the second iteration, the same load was applied to the side portion of the helmet by fixing the bottom padding. So in both the iterations, the maximum deformation value, that is 16.223 mm and 9.032 mm, were within the acceptable BIS limit, which is 24 mm. Next slide, please. So this is the stress and strain analysis for the second iteration. So the maximum stress value is 157.28 MPa, whereas the maximum strain percentage is 4%, which is quite safe and acceptable. Next slide, please. So the dynamic analysis was also carried out. The helmet was made to hit a concrete block at a speed of 10 meters per second, and the maximum stress value was recorded. So this value, which is 2.75 GPa, is within the acceptable limit given in one of the research papers on this topic. Next slide, please. So this is the comparison of our helmet with the other existing helmets in the market based on factors such as price, weight and features. So our product is priced in the mid-range. It would be one of the lightest helmets in the market. Next slide, please. So now I hand it over to Ninad. Thank you.
So we are currently in the prototyping stage and started with the testing. Not limited to this, we have planned to publish another paper, an extension to this idea only, by adding our new input to this idea, that is AI and ML tactics and the CFD analysis to reduce air drag. So we have started the work. We are going to use this for knowing the area where the most help is needed. That is where to first design the first port. So in which area the port is to be designed. So we are currently working on the only one area, having around 250 plus data inputs, that is data samples in our data set. So this is the data set. So we circulated a form, or we can say a survey form, through which we understood points like the age, the gender, parameters. So we can call it as parameters. So gender, days, when the user drives his bike the most, then the traffic condition in that particular area, then the commute time, whether the user wears his helmet or not, then has he faced any accident, and the most important is the area. So this is our data set. The first step of ML is the data cleaning, which comes under data pre-processing. So the feature importance describes, so this is the first step, that is the data mapping. So in data cleaning, both the figures are having the same data set and same values. Only the difference is that on the right hand side, the data has been mapped, as machine learning understood only numerical values. So now the second is the first step of that is feature importance part. So which describe features are relevant. It can help with better understanding of solved problems and sometimes lead to model improvement by employing the feature selection. So in our case, the target variable is whether the help is needed in that area or not. So in Y condition, in Y axis, we have given the parameter as help. Now then, the X parameters will be decided by the feature importance. That is the random. We are using random forest classifier as the algorithm. So through which we understood that the daytime area, helmet, and the days where the rider rides his bike the most are the most important parameters to have the better accuracy. So through which we have given these only 4 inputs, and through which we have arrived at an accuracy of around 90%. So this is the prediction screenshot through which we are using Spider IDE. So you can have a look. And these are the references. Thank you. And this is our paper link, so you can have a look.
Yeah. Looks like good work you had done.
Thank you, ma'am.
Addressed almost variety of issues. I have a very basic question. like this GPS tracking and GSM and all those sensors, instead of putting on a helmet, why not to put it on a bike? Why on helmet? Because helmet is for that person's safety only, no?
Ma'am,
It is
ma'am.
only it is supposed to give the local protection. That is what I understand from the helmet design.
Yes,
It
ma'am.
is a local protection.
But ma'am,
And you are
we are
making it
also
a global
planning.
level. Oh,
Sorry.
is it really required?
No, ma'am. Actually, we are planning to not only in the road conditions, we are also planning to launch this product in the mining area where the most important the helmets are used, and there is no bike or we can say vehicle inside that mining industries. So we are planning both ways.
Acha. And secondly, which software platform you used
For
the
virtual platform, the Proteus platform is used.
platform?
Proteus.
Proteus. Acha.
Proteus for simulations and Anaconda, that is Spider ID for AI.
Okay. And this in when you will implement it actually, so that time which software you are going to use?
Ma'am, actually we have started the testing. So we are currently we are testing the vibration sensors SW420 as well as the GSM module. As the labs are actually closed, we are not getting actual help from college. So as soon as in the next week around next week the colleges will reopen and we are going to work on that same platform.
Okay.
Sir, question?
Yeah, Ina.
Yes.
Can you show us the photograph of helmet? Is it possible now? Because you want to see that where the sensor and other things are located.
Yes, sir. Yes, sir. So this one?
No. This is the model. The actual helmet.
Actual helmet, I was asking.
No, sir. Actual helmet, we are just testing the vibration sensors. When the actual testing will be done, whether the message is transferred to our personal mobile, then we will be planning to place all that sensors inside the helmet.
Okay, means still you have not chosen what kind of helmet will be there.
No, the mechanical team have been designed. So, sir, this kind of helmet will be designed, where all the sensors will be fitted in this format.
So you are not taking any present helmet and modifying it. It will be newly designed.
Yes, sir, newly designed by the mechanical team.
So you showed one picture where you did the FEA analysis. So
yes,
I found that you created or applied the load only on the front and side. What is the reason?
Yes, sir. For the static
at the time of accident, it may go in any direction, and it should
also did the dynamic as well, sir. Can you jump to slide 13, Nina? 13th, dynamic analysis. So here we actually we did the dynamic analysis where we took the helmet and we made it to hit the concrete block below at 10 meters per second, and so these are
But hello.
Yes, sir.
It should be tested from the all possible directions.
So, okay, sir. We'll surely try that, sir.
No, because that accident, whenever it's taking place, it may be in any direction. And
yes, sir,
finally, the helmet is important, but its impact on the human body, that is also very important.
Yes, sir. Sure, sir. So we'll do it, sir. Yeah.
Okay.
Thank you, Team E6. You can stop your presentation.
Okay.
I would like to inform that our third judge, Reshma ma'am, she just got an emergency call and she has to leave the meeting. So we'll continue with two judges, and for every participants, only the marks of two judges will be counted. So we will just move with our two judges, and next we'll have Team A8. Team A8.
Okay, thank you, sir. Thank you,
Team
ma'am.
A8, you can start your presentation, please.
Okay. My screen is visible.
Yes, it is visible.
Okay, first of all, my name is Gokul and I'm my friend Dayanandan. We are from Manali Ministry of Technology, Tamil Nadu. We are to tell about biometric technology. These are the content we are going to tell today.
Now we can see the introduction.
Yes, you can start.
Biometrics are automated methods of recognizing a person based on physical or behavioral characteristics. Biometric technologies measure a particular set of person's vital statistics in order to determine identity. Now we can see what is biometric. The word biometric is derived from the Greek word bios and metric. What is meaning of the bios? Life and measurement. Respectively, this directly translates into life measurements. Now we can see the history of it. The first real biometric system was created in 1870s by French anthropologist Alphonsus Brentillon and termed biometrics a distinguished field of study. The first classification method of fingerprints was developed in 1982 by Sir Francis Galton. Now my teammate is going to say the type of biometrics.
The type of biometrics: physical biometrics and behavioral biometrics. The physical biometrics is used for either identification or verification. Verification is that matching an individual date of birth to an individual name. Behavioral biometrics is used for verification. Physical biometrics are
Sorry. Hello, sorry to interrupt, but you are not properly audible, Gokul. And also, while presenting, you make this in the presentation mode, no? PPT, you make it in go in presentation mode. Secondly, check with your audio signal. Now start.
Hello, audible now? Hello? Hello?
Hi.
Now it's audible now? Hello, ma'am?
Yeah, it's okay. Make it a presentation mode. Go into presentation mode. PPT.
Physical biometrics, these are the types of physical biometrics: fingerprint, face, hand, and iris, name recognition. The authentication process of fingerprint recognition is whenever we keep a finger on the fingerprint sensor, it screens our finger. After screening, it goes for the scanning purpose. After scanning, it gives a richest image of black scale image. Association is nothing but a database stored already. Whether it matches, it gives access to it. Otherwise, it will not give access. It is a process of fingerprint recognition. Hand recognition is not, face recognition is nothing but it tracks your image or video. After tracking, it will look for the location of face location, size, and poses. That is face alignment. After aligned, it will give a feature extraction. Whether it is matched, it will give access to the face ID. Otherwise, it will not give access. That is, matching is based on database process already enrolled. All these processes are same. We are using fingerprints, hand, iris, vein. These are the changes, but all the processes are same. Hand geometry authentication is nothing but it is
and they can keep on sensor. It process. It will extract the process. The values are stored in the database. Again, another user is click on the sensor. It will process. After processing, it will give feature extraction. If his hand is verified with this database, and if it is same, it will give matching. Otherwise, it will not give. It will not give access to it. This is the result of hand recognition. Iris recognition is nothing but high segment. This is not the same as hand recognition. Instead of hand, we keep here our eyes. Same process is done in all the pain recognition is nothing but infrared light is kept in the sensor so that it capture our vein. After capturing, it gives a grayscale image. The grayscale image is given as extracted image. The database is matching. It will give the user access. Otherwise, it will not give access to it. These are the behavioral biometrics: voice recognition, signature recognition, and keystroke recognition. Voice recognition is nothing but to convert analog audio to the digital conversion, and the pattern recognition is nothing but the database. If the voice is assessed, if the patterns are matched, it will give access to it. The example for this is Alexa and Google Assistant. It is usually all over smartphones nowadays. Signature recognition is nothing but it converts the signing on the digital board. The sign is pre-processed. After pre-processing, you give a feature extraction. The extraction is tested. The tested is matching to the database data. Then it gives access to the person signature. This is signature recognition. Keystroke recognition is nothing but typing your password to keyboard. We are using that in laptops and computers. We are already enrolled the password, the pattern, and password. If the keystroke authentication is it will classify the password. If it is wrong, it will give access will be denied. If it is give, if the password is right, it will give access to it. These are the characteristics of biometrics. So, physical and behavioral. Physical are face, fingerprint, and iris and DNA. Behavioral is nothing but keystroke, signature, voice. Some of the biometric devices are iris, fingerprint, and face camera, retinal scanning. This is iris scanner. This is fingerprint scanner, and this is face camera, and this is retinal scanning device. Applications that we are using an apparent system in our college and schools. Most of the organizations using these techniques in government sectors and to government sectors in most of the industries. Biometric safes and biometric locks provide security to homeowners. It gives security for us. Instead of remembering password and PIN, we use biometric for easier way. Biometric access control system providing strong security at entrances.
Team 8, sorry to introduce, but time is up. Please complete your presentation within a minute, please.
Okay, ma'am. Dayanandan.
Yeah. Now you can see the advantage, madam. Increase security, provide a convenient and low cost additional tier of security, reduce password administration cost, replace hard to remember password which may be shared or observed, unequivocally link an individual to transaction or event. Now you can see the disadvantage. The main disadvantage is now many systems are going to be hacked. The one of the system is biometric. Cost is also a main significant for disadvantage. Tracking and data. Biometric device like facial recognition system can limit privacy for users. Now you can see the conclusion. Biometric can only be limited by limiting one's imagination. Biometric technology is now being used in almost every area. Nowadays, we are using more and more number of multimedia devices that support biometrics. Thank you.
Thank you, Team AA. Sir, I would like to request you to ask the question.
Yeah, Mr. Gokul. Hello.
Yes, sir.
So, can you tell me, summarize that what is your contribution in things we presented now? So, it happens to be the collection of the material information. That is very good that you've gone through it. But can you pinpoint what work you did and the reason for the presenting this paper?
What is to future biometrics, sir, like ear scanning, ear biometrics.
Okay.
The PPT we shared is that are in progress, sir.
Okay. So, did you carry out any work in any one of the area?
No, sir. Still, our college is not reopened, sir, so we are not working on it.
Okay, fine.
So you did some survey of existing biometric products, or what sort of work you had done up till now in this top?
Existing
Products you compared or studied. You could have compared based on the technology used, based on the cost. No? That type of survey you could have done, no? If it is a survey paper, you should have done the survey with some reality, no? It's okay.
Thank you, team. Now I would request team B7 to please